So let's think about my unit circle. Oh, it's so good. And we know that every point on here is x and y. Hopefully we're to the point now that we know every point on there is cosine and sine, because x is cosine and y is sine. So when I talk about the domain, right, the domain would be, what if I thought about the function as like y equals sine of x, or y equals cosine of x? And it's kind of weird switch in your brain, because you think x and y as the point of a circle, but when I write it as a function, we're thinking about x as the domain. What values can I put in for x? What kind of values do I get out for y? So if I'm thinking about the domain here, I'm thinking about the angle, right? What kind of numbers am I allowed to plug in there for x? Am I allowed to plug in decimals? Definitely. Whether in radians or degrees, you can plug in like 75.5 degrees. Could I plug in negative numbers into my angle? Can I take the sine of like negative 2 pi thirds? Don't need calculators. Take the sine of negative 50 degrees or negative something. Do you get a number out of it? Is there anything you're not allowed to plug in for an angle? Can I plug in a million degrees? Or a million radians? I could plug in any decimal, any fraction, any number into the angle, and I will always get a value back out of it. Which means if I can plug anything in for x, what does that mean the domain of sine and cosine is? All real numbers. Which is kind of cool. Sine and cosine are only three functions. Now the range is the value we get out of it. So the range is not all real numbers, and we can use the unit circle to figure out our range, because no matter what I plug in here, right? This is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. This is the point 0, negative 1. Right? And any angle we can think of will fit on here, because, you know, remember we can just keep adding 2 pi or subtracting 2 pi. And hopefully you saw this on your worksheet. What's the biggest number that we ever get for sine? 1, right? The biggest number we ever get for sine is 1, and all the ones in between here are less than 1. Square root of 2 over 2 is less than 1. Square root of 3 over 2 is less than 1. And all the ones in between there. And the smallest value that we're ever going to get is negative 1. And the same thing is true for cosine, which is the x-coordinate, which is why, you can kind of see here, but it's why we say that the range is negative 1 to 1. Which, if your calculator's in degree mode or radian mode, whichever one you want, you can type in the biggest angle you can think of, and its sign will always still be between negative 1 and 1. You're never going to get a value bigger than that. Another reason, just to kind of show you where this comes from, think about if you drew a triangle. And this was my theta. Sine is the opposite, or we're going to say y over r. Doesn't y always have to be less than r, or if it was up here at 90 degrees, y becomes r? Like, there's no way that this side can be bigger than the hypotenuse, which is why the range can't be bigger than 1. That would mean that the opposite side is bigger than the hypotenuse. That's another way to think about why that's true. Okay, so since we can say that the y, meaning the sign, is between negative 1 and 1. I've learned a lesson from people being absent. If I do the fancy little trick where I just pitch it and it disappears, that when you go and print off the notes, it's covered up. Like I showed you the video. So we know y is sine, so we can say sine is between negative 1 and 1. We know cosine is x, so we can say cosine is between negative 1. And we've kind of already talked about this. We just just haven't put this word with it. But why does this work? Why does the unit circle work for anything? Because if we just add 2 pi or a multiple of 2 pi, we always get back to one of these places on my circle, whether it's 30 degrees or whether it's a weird angle like 72 degrees. 72 degrees, I don't know the value of it, but I know at 72 degrees, if I add 360 degrees, I'm going to keep getting back there. So this idea that sine and cosine just keep repeating themselves, is a special word for it. We call those periodic functions. Another word that they use for that is a wrapping function. I like wrapping like we want a wrapper. I like wrapping because it just repeats itself. Right? Think of like a bowl of wrapping paper. Just wrap. Periodic functions just keep repeating themselves. And what we kind of want to be concerned with is how long does it take for it to repeat itself? And we know the answer already. How long does it take me to get back here? 2 pi, which is why if you just multiply by any multiple of 2 pi, and we can get back there. Or we keep adding and subtracting 2 pi there. All right, so really short notes today, but kind of really important vocabulary there. So this next one is just the formal definition of a periodic function. And so it says a function is periodic if there exists some positive r, meaning real number. Do you know the symbol for a real number? Like it's not really just a regular r. It's like a double barred r. Have you ever seen that before? It's all fancy, special font for that. So that just means real number. So if you want to write the word real number in there. So if a function is periodic, if there exists some real number that when you add that real number to the function, that you get back the same value. So that f of t plus c equals f of t. We want to know what's the smallest number it takes to get there. And for sine and cosine, for basic sine and cosine, we already know the answer to that, right? We already know that that's going to be 2 pi, but we say that that is the period of the function, how long it takes to repeat. And for sine and cosine, we can say that we know that that is 2 pi. Really funny story. You guys know Mr. Gillis? That's too long ago. He taught precalculus when he was teaching, and he told us this story at lunch once, and it just made me laugh a lot, and I can't help but think of it every time I teach this. Sometimes, when you do transformations to sine and cosine, which we're going to do in the second half of chapter 4, isn't that so exciting? Stretching and shrinking and translating sine and cosine graphs, which means that the length of the period of sine and cosine can change, right? It's not always 2 pi. Sometimes it's longer, sometimes it's shorter. So he was at his class, teaching his class doing teaching, and his teacher was in university campus, and he was looking at him, and he was having like a lot of and he's back there, and he gives him a problem, and he's like, so, what's the period of this? And of course, just like you guys, they just sat quietly. And he's like, come on, guys, we've been doing this. What's the period? What's the period of this function? And nothing. And so he gets really animated, and he says, how long is my period? And they all laugh. So I never really thought of it that much before until now, because of Mr. Realist, I think of that all the time, and it's funny to say because you say sometimes the period of sine is shorter, and sometimes the period of sine is longer, and always getting uncomfortable, and so. But anyway, that's my Mr. Realist memory here. Okay, so what this says to us is something I hope we know already from coterminal angles, but it says because the period is 2 pi, when I take the sine of pi, it's the same as taking the sine of 3 pi, or 5 pi, or 7 pi, or any odd multiple of pi there. It's always going to be the same thing, because no matter what, I'm always over here, right, at pi, or if I add 2 pi to that, I'm at 3 pi, 5 pi, and I'm just right there every time. And what is the sign of all of those? The point is -1, 0. Which one is sine? Sine is a y-coordinate. So the answer to all of that is 0. So there's some of your homework today that I think we skipped, right? If you look at the assignment sheet, like we kind of just tore that fourth grade apart of breaking it up from 2 days to 4 days. But there's some that we skipped that today I'm going to give you that are really big multiples of pi. And I think every single one of them you should be able to add or subtract the multiples of 2 pi to get back to somewhere on the circle that you can take the sine or cosine of it by just finding the x to the right coordinate. And then the only other thing that I want to talk about before we have a test is even and odd functions, and I feel like those should be spread out more. But an even function, and again, this is going to help us when we're graphing, but it also can help us sometimes now. An even function is, right, one of my favorite even function is y equals x squared, because even means it's symmetric with the y-axis. Even means when you plug in a negative, you get the same thing when you plug in a positive. So definition of an even function, we say that when you do f of negative x, you get f of x. I think this was like chapter 1 for us, we did even and odd functions. So for x squared, right, we know that every positive number has the same value on the other side. It's symmetric with the y-axis. There are only 2 even trig functions, and they're right here. Cosine and its reciprocal are even, which means when you take the cosine or secant of a negative angle, it's exactly the same as if you took the cosine or secant of the positive angle. Probably right now you're not going to think about that much when you're evaluating it, because you're either going to make it positive or you're just going to think about where it is. And when we start graphing cosine and secant, it's really nice to know that it's even, because it means if you know what this side of the graph looks like, you just flip it over and it looks the same over here, which is where we'll start. I always remember, cosine and its reciprocal are even. The rest of these functions are odd. So what does it mean to be odd? My favorite odd function is x cubed. What x cubed looks like. Which means definition of an odd function is that for every positive value you plug in, you get the exact opposite value out. Which means when you do f of negative x, it makes the whole function negative. So that's negative f of x. That means for an odd function, if I'm taking the sine or cosecant or tangent or cotangent of a negative angle, it's the same as if I took the negative sine of the positive angle. And we're going to write some examples. And I'll show you how we can use this, but then I'll also show you that if you know how to evaluate trig functions already, you don't really have to do this right now, but it's just something I think we're going to talk about as we're graphing. Because when we're graphing all these functions, an odd function means whatever happens over here, we just do the exact opposite of this side, like just flip it down there. So again, it's helpful when we're graphing. Okay, so let's do a couple. So let's do the cosine of negative 5 pi thirds. I'm going to show you how you can use even and odd functions, and then I'll show you how you don't have to do it ready if you don't want to do it. So, is cosine even or odd? Cosine's even. So if you remember that, you don't have to stress about it being a negative angle, right? I don't like negative angles because I go the opposite way. I always want to make it positive. If you can remember that this is even, then that means that the cosine of negative 5 pi thirds is the same as the cosine of 5 pi thirds, which means I don't have to stress that it's a negative angle because I know it's just going to be the same value as the positive angle. Which means I need to know where 5 pi thirds is. Where's 5 pi thirds? 6 pi thirds is 2 pi, so 5 pi thirds is down here. So if I'm a circle person, I need to know what the ordered pair is, or at least need to know what the part is. Again, for me, I never draw the whole circle out when I'm doing a problem. I just do what I need. So if this is 5 pi thirds, I know it's the same as the one up here, and I remember the shortcut that it starts with 1/2, right? So that means this is also 1/2. So y is negative, so 3. remember, that's the ordered pair for 5/3, but that's not the cosine of 5/3. The cosine is which one? Cosine is the x, right? Cosine is x, sine is y, which means cosine is half. So the answer here, I kind of want to look here. If, yes. All the thirds have the same ordered pairs. So you're right. If you want to think about it, this one, right? Like that's 2/3. And here it's 4/3. All of them have the same ordered pairs. I always go back to the first quadrant for me because that's the one I know the most. But it totally works if you know that it's over there, if those lines match up, and you know that ordered pair. Okay? So just another way to think about it. If you say, I'm not going to use this even crap right now, right? I have enough in my brain, I can't do any more right now. You know how to do this already, because either one, you could graph negative 5/3 by going clockwise and find the ordered pair, or two, how can I make that a positive angle? You could just add 2 pi to that. If you added 2 pi to that, you would get 5/3. Which is right up here, and guess what? The cosine is still 1/2. So you don't have to use this even and odd stuff right now, but I'm just telling you, it's going to come in handy to know which ones are even and which ones are odd. But you could still evaluate it without doing even. So what about sine of try to do the third. Let's just go to the fourth. 3 no, that is negative 3/4. If we use even and odd stuff, sine is odd, which means, right, if you don't want to deal with the negative angle and you want to do the odd part, because it's odd, we can say this is the same as saying negative sine of 3/4. And again, if you know what 3/4 is, you know which one is sine, then you just take the opposite of that. So 3/4 is quadrant 2, right? So this is 5/4. So 3/4 is right there. And what's the ordered pair at the 5/4? Yeah, that's my favorite one. Square root 2 over 2. In quadrant 2, that would be negative square root 2 over 2. Square root of 2 over 2. And sine is which one, x or y? Sine is y, which is positive square root of 2 over 2. But because it's odd, you have to take the opposite of that. So you're going to take negative of sine of 3/4, which means you should get negative radical 2 over 2. That's the idea of how you can use even and odd functions to help evaluate it. But again, as long as you're getting the right answer, I don't care if you're actually using even and odd or if you're just saying, well, if I add 2 pi to this, isn't that 5/4? 2 pi is 8 pi over 4, so 8 minus 3 is 5/4. And if I graph 5/4, guess what the sign is? It's negative radical. Right? So, again, it's just another way to help you, but I don't want you to feel like you're tied to this even and odd stuff as long as you can get this answer out of it. These would totally be on a no calculated part of your test. And as we get closer to the test on Thursday, those two, like, make sure what you do. But pretty much anything with the circle, anything with the special angles, it's going to show up on the most calculated part. So I think finally, this is going to be through all the homework. I call this day 3 continued, also known as day 4. I think this should end up all the questions that I have on your homework sheet. 37 through 42 all. Those are all really big numbers, or really small numbers where you're supposed to be able to add or subtract. Or I. And then 49 and 50 are questions talking about what if you had a really, really big, gigantic angle, could you figure it out? And again, it's the idea that you can just figure out the functions to help us. So it's not that many homework problems, and you have a ton of time left in here today. So get those done, ask questions so that tomorrow you can get started on 3.